Hi, we're back again. I'm doing another video podcast talking about using openFrameworks C++ framework toolkit for creative projects. This is part of a series of the Creative Technology Toolkit, looking at lots and lots of different basic aspects and trying to run through them with a goal of talking about creative applications of them, rather than specifically being something that will explain everything about C++. Today I'm going to run through another example from the Creative Technology Toolkit Module, which is running at the University of West of England in Bristol. All of the source code for this is available online, and this time we're going to be looking at using randomness and talking about making a classic two-dimensional random walker. So without further ado, I'm going to go to openFrameworks, and in the My Apps folder, I've already downloaded the CT Toolkit sessions. You can clone them or download them and add them in. We're going to have a look at session 6, and inside session 6 is all of the files that you'll need to make this run on Mac, Windows or Linux. The important things are here, just these 3 files in the source folder, and you can move them into other environments. I'm working here on Mac in OS 10, using Xcode, but you can equally use Visual Studio Code, Visual Studio, or any other preferred text editor. What we're going to do is we're going to make something that ends up looking a bit like this. What this is a random walker. We're going to use a randomness function to start from a specific point on the screen and jump to another point and draw a line to it somewhere randomly on the screen within a random distance. Then from that point, jump on, and there's actually a lot of maths going on behind what's happening here, but we're just going to look at the simple effect, and I'm going to do another video later on which talks a lot more theoretically and artistically and mathematically about some of the issues that we've been playing with. We're also going to introduce a thing called Perlin Noise, which is a way of getting slightly less random randomness, which is an odd idea, but I'm going to talk a little bit more about that as well. And if you're trying to make natural looking motion, Perlin Noise can be your very special friend, and it's implemented in openFrameworks really, really simply. So to look at the code, I'm going to fire up Xcode, being the development environment I'm working in, and the 3 files that I'm looking at are, again, we have a standard main, which launches a window. In my header file, it's very standard. The only additional thing beyond the standard update, draw, setup, I've asked openFrameworks to make me a vector, so a list called drunkard steps, and in that list I'm going to use the openVec2 object. So this is a 2-dimensional vector object. So basically it's just a point. In this instance it's going to be a point, a pair of x and y values brought together, and I'm going to make a list of lots and lots of points just containing an x and y value. openVec3 is 3 points, so an x and y and z, and this example works equally well in 2 dimensions as it does in 3 dimensions. And then I'm adding 3 custom functions, or the first is add step, the second is add stagger, and the third is add noise step. And then I'm just going to add in an integer called stagger size. There's a couple of bits I've got commented out down here, which if you have a look at this source code, you can walk through yourself and uncomment them and add things to the complexity of the application that we've got here. But this is just to simplify in our initial setup. So I've made a vector that's going to have points in it, and I've got these 3 new routines defined in the header file. And in the app file, in the setup, it's pretty simple. All I do is make a new point. So I say I want to make a new vector2 object called new point, and I'm going to initialize it with the values 0, 0 in it. And then I'm going to take my vector, which is this list of all these points. At the moment it's empty, but I can push points into it, pairs of these x and y coordinates, and using the vector method pushback, I'm going to say take the point that we've just made at 0, 0, push it onto the back of this list. Because the list is empty, it'll be the first point. So we now have our drunkard steps vector initialized just with our first starting step. And then I set stagger size, and this is how far, when we go on our drunkard's walk from point to point to point, how far we should stagger. Play around with this initially and see how does that affect the behavior and how it looks. The update loop is doing nothing, and the draw loop is doing a couple of simple things. I'm going to set up two integer variables, previous step x, previous step y, and I'm going to get the width of the screen using ofGetWidth divided by 2, which will give me the middle of the screen, and the same with ofGetHeight, it'll give me the height of the screen, divide that by 2, and that'll give me the middle of the screen in the x and the y directions. And I'm going to initialize those two integers, and then I'm going to create two more integers called the current step x and the current step y, and just pre-initialize those by copying the values out for the middle of the screen. So I have my four variables, previous step and current step for x and y, and they're all initialized. And then I'm going to make a for loop here, and it's going to start at 0, have a look at the drunkard steps vector, and ask, using the size method, how big is it, please? How many points are in there? Initially it's just 1, so it'll just make 1 pass through, and then I'm just going to say iterate through all of the steps that have been pushed into this list of steps. And then I say get the current step and take the value from whichever step in the list, the drunkard steps vector we're walking through, by saying drunkard steps position I, get the value of x, drunkard steps I, get the value of y, and we push that into the current step variables. Then I'm just going to set a color to draw in, and I'm going to say draw a line from previous step x, previous step y, to the current step x, current step y. So OF draw line means starting x and y position and an ending x and y position. So it draws a line. And then an additional thing is I'm going to ask our program to draw the number of each point next to where the end of the line is. So I set the color to black using OFSetColor, and then I say OF draw bitmap string, and if I wanted to use a custom typeface I could do. We've seen that previously where we use OF font and load in true type fonts and other kinds of fonts. So I say draw a bitmap string, the number I, whichever step we're at the current x and y position, and then because we're going to loop through from our last point to our current point, that move back and we get a new current point, go from our last point to this one, and so on. I'm going to set the previous step to whatever we've just used as our current step and start all over again by getting new current steps from our next position in our drunkard steps list. So we're going to make a list of points and then go through getting the first one, the next one, and going from the previous one to the current one, previous one to the current one, all the way along. So that will draw, and then here I've just used the OF draw bitmap string again to write a little bit of debug text onto the screen. So in quotes I've got what I want, and then I'm using this escape character to make a new line /n, so it won't just run all the way across the screen. So in the text it'll parse it and come to /n and make a new line, and then I draw it at this position on the screen. In the key pressed routine here, again I'm using the switch statement, so it's evaluating which key's been pressed, and if the case is that it's a spacebar, I'm calling the function add step, and then we use break to break out of the loop. If the case is M and I press the M key, it uses the add stagger routine, or the N, add noise step. And then down here you can uncomment these and add them yourself, pretty self-explanatory. Again we see our friend OF toggle full screen, so that when I press the F key I can make it full screen or not. And then this is a common thing that I find really useful if I've got tools or notes that I'm making in the program to help me remember what on earth it does. I'll make a Boolean value, which is normally called b underscore draw GUI, and I use the b underscore to denote for me that it's a Boolean, i.e. this integer can be, this variable can be on or off, 1 or 0, nothing else in there. I use this to show or hide on-screen controls or menu controls and other things, so I can be working and twiddling with the code or the project or the piece of artwork that I'm making, and also hide all of that stuff when I want to be able to sit back and really consider whether aesthetically or artistically or creatively the project is going where I want. So at the moment we're just detecting these 3 keys, and we call these 3 new routines that we added in, and here they are down and defined. The first one, when we press the spacebar, I'm going to call add step. It's going to generate a new step and add it into the list of steps that we've already got. So I'm going to make a new OF2 vector called new step, and in that the X value is going to be this bit. So I'm going to say make me a random number using our friend the openRandom command, and I can either give it one value and it makes a random number between 0 and that value, or I can give it 2 values to say make me a random number between this value and that value. So I'm going to say make me a random number between whatever is half the width of the screen and a quarter the width of the screen added together, and go between that and the height divided by 2 plus a quarter of the height. So that will make me 2 random numbers and add them into this point or this vector2 variable called new step. So I've got a new point number with an x and a y randomly generated, and then I take the vector drunkard steps and again use our friend pushback, and I just say take this new point value, this xy pair, and stuff it onto the back of the end of the list of drunkard steps, which means next time we run our draw routine, it'll see that new step and loop one more time. So simply when we press the space key, it makes us a random step within a certain amount of distance anywhere on the screen. If we add a stagger using the add stagger call, we do something different. Now let's compile it and have a quick look at what the add step does when we press the spacebar. So compiling our code, building our code, our first point was 0, 0, which is up in the top left of the screen, and you can see it's drawing to the middle of the screen. And if I press the space key, it'll make me a new random XY point anywhere on the screen, just a quarter in on the width and the height. So when I press the space bar, it's making me random points and walking from point to point and numbering them each time in the order that's drawing them. So that's kind of nice, and that gives me randomness, but it's a lot of randomness. It's very edgy and very sharp, and there's no natural seeming flow to it. What I can do is make that a little bit more complicated. Rather than just saying make me a new point anywhere on the screen, if I add a stagger, which we're calling when I press the M key, I'm actually going to say go from where I am now to somewhere a little bit near where I am now, rather than just somewhere randomly anywhere on the map. So again, I make a new OF2, OF vector 2, so an XY pair that I'm going to use, and I call it last step, and I go to the drunkard steps vector, find out how big it is, and go to that last point -1. So it'll return, there's 10 points in there, but because it starts at 0, I need to go to point 9 to get the last value from it. So even though it's going to return me 10, because we start at position 0, the last position in 10 places will be position 9. So I grab the position of our last step that we made, and then I make a new step, and I say go from where our last step was plus a random number between minus stagger size and plus stagger size. If you remember up at the top in the code, we set the stagger size to be 60 pixels, so it'll return me a number at the last step X position minus 30 or minus 60 or plus 60 from that point. So it'll be wherever that point is and in a circle essentially around it. And we do that with the X value just here, and the same, we grab last step dot Y, which we've pulled out of the last drunkard steps, and we add either anywhere between minus 60 and plus 60 to it. So we're randomly going within a region around the previous step, make a new one, then within a region of that, new one within a region of that. And then, just like we did before, we take the drunkard step vector and push back our new step on the end of it. So when we press the M key, that's what we get. We get the add stagger. So I'm plotting this to the screen, but these could be musical values, these could be movements of a robot arm, it could be edits in a piece of video, it could be anything the way you want to generate complexity. So now when I press the M key, I take the stagger and you can see it's not diving all over the screen. It's going within a certain amount of that last point. And I get a little bit more coherence than if I now switch to pressing the space key. You can see I'm firing and diving all over the place. But if I go back to pressing the M key, you see I get a different kind of randomness to it. But the randomness is interlinked. Essentially, this is associated with Markov chains, which I'm not going to talk about now, but it's a way of looking at randomness linked to randomness. So I'm going to quit that now and come back and look at the last thing. Now, what I'd like to do is find something that is random, but it's not so angular, not so noisy. And there is a thing called Perlin Noise, which is named after its inventor and creator, that is a very, very fast algorithmic routine that gives me randomness, but relatively smooth. And essentially, Perlin Noise will give me a number between 0 and 1, but it will move incrementally backwards and forwards between those two variables smoothly, depending upon the granularity that I want. So I can either make it very, very slowly drifting between two values, or I can accelerate it, and it gives me a smooth wave, but much faster. There's a lot been written about Perlin Noise, and I'm not going to go into it greatly now. I'm just going to say it's a routine that we can use that's written into openFrameworks, and it's very commonly used for, I think it was originally built for using generating surface textures for 3D, where you want smooth randomness within parameters, but you don't want a massive computational overhead. So our purposes here, it's kind of useful, and this is a very, very simple use of it. And there are many other uses which we'll try and do some videos about in the future. So we're going to add a noise step, and again, we do exactly what we did last time. We get the last step by looking at the drunkard steps vector, grabbing the size of it, -1, and put it into last step point, vector 2 point. And then we make a new vector 2 point based upon where our last step is, and instead of using the OF random function, we use the OF noise function, and we feed it our last point, and then we take away a little bit from it, and we multiply that, which will give us a number between 0 and 1, and now that's going to give us a number between minus 0.5 and plus 0.5, because you've taken a half away of the between 0 and 1. We're using our last step as a trigger. So OF noise needs a trigger. Often this is fired by people using the time function, which just increases incrementally. We're going to increase the length of our distance from our last step point just by adding the stagger size. We do the same with the Y. And then we take the drunkard steps list, use push back, and again push our new value onto the back of it. So it's getting longer and longer and longer. And in our draw routine, we just loop through because we ask the drunkard steps using the size. How big is this vector? How many points are in this vector? So if you run that now, compile and run, you can see the spacebar is giving me big, very random steps. The M is giving me these interlinked staggers where I am now to somewhere near where I am now. And if I use the N key, and I'm just going to let it run, the Perlin Noise starts to give us a direction that loops, and we get much smoother kind of motion where we're getting interlinked steps in a consistent direction, whereas if we use some of the other routines, it's much more random. So that's a really, really simple look at using drunkards walks, which are one of my favorites from way back when I was a kid starting to make artwork on very early computers, of being able to get interesting stuff coming out. And you can map these numbers to drawing on the screen, to selecting words out of a list of words, to making colors, to making edits on video, to being triggering sounds, to being MIDI notes, to sound files, to operating lights, operating motors, all kinds of things where you need randomness. So that's a little start. In the rest of the code, there's a couple of additional things that you can do. Add in these cases for full screen toggling, for showing and hiding the GUI. And in the header file, what I also do is use the EasyCam. I'm going to uncomment that now. And also the ability to load a TrueType font and use different fonts to draw to the screen. If you put the EasyCam in, you'll see one of the lovely things about openFrameworks is, even though we're drawing in 2D, openFrameworks is essentially 3D all the time. And the EasyCam just gives me some simple utilities like a first-person shooter cam. And if I click on the, oh, my bad, I've declared the EasyCam here in the header, and I've forgotten to switch it on. So in the draw routine, I just say, I'll comment that line, cam, or whatever we've called our camera, please begin working, and at the end, please stop working. So now, when openFrameworks comes into the draw routine, it'll start using this camera, and we can use the camera to make 3D transforms of what we're looking at. So you can see if I click and drag, I can zoom in and out, and even though I'm drawing in 2D, actually what I'm drawing is drawing in the XY plane, and now I'm being able to manipulate where I am in the Z position, and I get my drunkards walks that I can see in 3D space. And in this example, we're using the OFVec2 class, which is a pair of points, but you could use the OFVec3 class object, which is 3 points. So instead of just plotting X and Y, you could plot X, Y, and Z, and you can do a drunkard's walk in 3 dimensions, which would be a kind of interesting thing. And if you plotted that space to say, this is a list of video clips, you could then use a drunkard's walk to go through and choose video clips, or choose audio, or anything else that you can think of. So that's drunkards walks. It's randomness, a really quick and very bad introduction to Perlin Noise, but we'll talk a lot more about much better examples of that later. Have a look at the code, have a play, and have a work around what you can do with randomness and linking randomness to randomness. And you can start getting some really, really interesting spaces to enjoy making creative things. So the code is all online, the URL will be on screen, and please do leave any suggestions, comments, bug fixes, corrections, etc., or suggestions of things that you would like to see more videos of in the future. Thanks very much.